Good day everyone, I am Ana V. Espagliardo. Today, I will be discussing an important topic in trigonometry, the graphing of trigonometric functions. We will explore their periodicity and amplitude, analyze their general behavior, and determine the domain, range, and key characteristics. Additionally, we will examine how changes in period and amplitude affect the graph of this function. So let's get started. To begin, let us recall the 6 fundamental trigonometric functions. These are the sine, cosine, tangent, cosecant, secant, and cotangent. Each of these functions has unique graphical characteristics that are based on their periodicity and amplitude. The most fundamental functions are the sine and cosine. Which can be defined as this. So, y equal to a sine bx plus c plus d, and cosine y equals a cosine bx plus c plus d, or A represents the vertical stretch or the amplitude, and B is used to calculate the period or the horizontal stretch or compression, and C is the horizontal shift, and D is the vertical shift. So to graph this function, we will follow these steps. So first, identify the A, which determines the peak. And then second, find the period using the formula 2 pi over b. And then identify any shift caused by C and D, and lastly, plot the key points and smoothly connect them. So for example, but before that, we need to know what positive sign looks like. So, the positive sign looks like this. We will start at the center, then it goes up, and then down, then back at the center. So this is the positive sign. The negative sign is like this. So we will also start at the center, but unlike the positive, we will start at the center, then down, then up, then back at the center. So this is what the negative and positive sign looks like. So how about the cosine? So cosine looks like this. Cosine doesn't start at the center, rather it starts at the top. So, like this. And then it goes down, and then back to the middle, and then up, and then down, and then back to the middle. So this is the positive cosine. The negative cosine is like this. So like the negative sign earlier, we will start at the bottom, and then it goes up and down and up and down. So this is the negative cosine. So another example, y equals sine plus 1. So here is our graph, and the first thing we need to realize is that it's been shifted up 1, and the line which we're going to call the midline is now at 1. So the amplitude is 1, and the number in front of sine is 1. So To find the upper limit, add these two values, so 1 plus 1 equals 2. And to find the lower limit, subtract 1 minus 1 equals 0. So it's going to vary between 0 and 1. So this is the upper limit 2 and the lower limit 0. The number in front of x is 1, so 2 pi over 1 is going to be 2 pi. So our period is 2 pi. So it is 2 pi, and the half of 2 pi is pi, and the half of pi is 2 pi over, I know, it's pi over 2, and then pi over 2 times 3 equals 3 pi over 2. So we'll start the point here, and then up, and then in the middle, then down, and then in the middle, and then we will start up and up again. And that's it. Now, we will move on analyzing the general behavior of trigonometric function graphs. Each of the 6 trigonometric functions has distinctive graphical behavior. So sine and cosine are smooth, continuous, periodic waves oscillating between their maximum and minimum values. So sine function has a waveform whose amplitude increases until it reaches the maxima and decreases until it reaches its minima. A sine wave basically has a value of 0 at x-axis that goes up as the value for x increases until it reaches the pi over 2. So a sine wave starts and ends with an amplitude of 0 within one period. Basically, a sine function completes its cycle at 2 pi. So here is the example graph. So this is the amplitude, and 2 pi, so this is the 2 pi, negative 2 pi, and then the point starts here, and then here, so we'll connect this. And that's it. This is the example of the sine function. So the cosine function, how about the cosine function? Cosine function is unlike sine functions that starts with an amplitude at maximum and start and end on complete cycle. It looks like a sine wave that is defined 1/4 of each cycle to its left. So basically, a cosine function completes its cycle at 2 pi. So for example, this is the Cartesian plane, and this is the amplitude, and 2 plot here. Then connect again. So this is the example of cosine function. And the tangent function, tangent and cotangent is defined only at certain points that exhibit vertical asymptotes where the function is undefined. So the graph of tangent function is asymptotic to pi over 2. So this is because of the infinite value for tangent function at the angle of pi over 2. So basically, a tangent function is complete its cycle at pi. So for example, this is the graph. And then I will just the asymptotes. And this is the full cycle of tangent wave. So this is the example of the tangent function. And the cotangent function so the graph of cotangent function is asymptotic to x, 0 at x pi. This is because of the infinite value for the cotangent function at an angle equal to 0 and pi. So basically, a cotangent function completes its cycle at pi. So this is the example of graphing the cotangent function. Okay. So this is the one cycle of the tangent wave. So this is the example of the cotangent function. So to graph the cosecant function to 0 and x equals pi over 2 and f is equal to pi. This is because of the infinite value for cosecant function at an angle of equal to 0 and pi and 2 pi. Basically, a cosecant function to place its angle at 2 pi. So this is an example of the graph of cosecant function. So this is the example of cosecant function. So how about the secant function? So to graph the secant function is asymptotic to x equals pi over 2 and 3 pi over 4. This is because at the infinite value for cosecant functions at an angle equal to pi over 2. So basically, a cosecant function completes its cycle at 2 pi. For example, this is the graph. And this imaginary line. So this is an example of secant function, the graphing of secant function. So that's all for our discussion. I hope you now have a suited understanding of how the property sketch trigonometry function, graphs, and analyze their general behavior, including asymptotes and periodicity. Additionally, we determine the domain, range, amplitude, and period of each function. Furthermore, we explore how changes in amplitude and period affect the overall appearance of the graphs. So that's all. Thank you.